This is Dave Snyder from Siemens Preactor, and today's webinar is on the fundamentals of production scheduling. So we're going to look at what the difference is between planning and scheduling, why production scheduling is important, what are some of the tools used commonly to do production scheduling, and then we're going to look at advanced planning and scheduling, what that has to offer, what the benefits are. So let's review. Some of you may have been part of the webinar series going through the fundamentals of manufacturing. Manufacturing is taking materials, equipment, and labor as input. You apply a process to those inputs, and on the output you've got a part or a product. And quite often you've got a byproduct of scrap or waste. Production scheduling has the same inputs to be concerned with, materials, equipment, and labor. Those are typically constraints to the process. And what we're going to look at is planning our process. Now, if we look at the functionality that a manufacturing plant has, most of you in this webinar are going to be familiar with the green space at the top, the PLM functionality. What is new to most of us is the MES space, the manufacturing functionality. But we also need to be concerned with ERP functionality. And in this diagram, we see that production scheduling often sits in the ERP space. Often we think of it as sitting between the ERP and the MES. And other functionality that is quite close to production scheduling space is production planning, capacity planning, and sales forecasting. So some important terms that we need to be concerned with as we're looking at this space. You know, when I think of this, I think of my youngest daughter graduated high school this past May, and as you can imagine, my wife decided to throw a party. So one of the first tasks she did was she added up, she made a list of everyone she wanted to invite to the party. Then she got some feedback on what other parties were going to be conducted that day, that weekend, who was going to be out of town, and she made a projection of how many people she felt would attend. That is a sales forecasting function. Whether you're doing it in your head, whether you're doing it on a piece of paper, using an Excel spreadsheet or a more sophisticated tool, you're calculating what the demand is going to be for your product. And then based on how many people she thought would attend, she made a calculation of how many chairs were going to be needed, how many strawberries, how many other purchased materials. That's your materials requirement planning. And then as we were looking at the calendars, as the party approached, she determined which days we had available to go shopping and pick up materials, how many hours each of those evenings, the various stores we had to stop at. And she determined whether we could get all the shopping done or whether we needed to call in friends and family to help with some of those tasks. So, you know, at a high level, that's your capacity planning. And then when we were at the store, she gave me a list of items to purchase, the sequence I should go purchase them so that I was most efficient in my working through the task list. And as well, on the day of the party, I had a task list that included picking up the ice, setting up the tent, the other tasks that had to be done in a specific sequence, depending on dependencies between different tasks. So, you know, that's production scheduling. You're actually sequencing your tasks. Planning and scheduling, those terms mean different things to different people. So let's dig in a little bit deeper what the differences are in those terms. Planning is looking out longer term. You're using bucketed time. In my example, day of the week is bucketed time. Deciding which stores we have time to go to on a given evening, that's a planning task. So maybe a manufacturer is looking out 6 months and looking at their projected shipments, even before they've got sales orders. Maybe if you're making barbecue sauce, you see there's going to be a spike in the spring when the warm weather comes. And it allows you to make some decisions of, maybe I should be making something early, or I should be moving production to another facility to accommodate this spike in demand that we're going to see. Scheduling is taking actual sales orders, you're putting them in sequence. It's got to honor all the constraints. In essence, you're creating a work-to list you can release to the shop floor. So if we drill into that a little bit more, you've got your forecasted demand, whether that's coming from another system, whether it's coming from Excel spreadsheets. You've got your planning periods. You've got your capacity rates. Those come in, you make some decisions. Basically, you put together what is called a master production schedule. And don't be confused by the schedule in that title. Master production schedule is a planning function. And coming out of that planning function, you've got your suggested orders that are going to go to the ERP, and the ERP is going to do MRP functions, create those work orders, and also order all the purchase materials to support that. Now, this planning function supports looking out 6 months or whatever your time period is, whether you should be hiring additional workers, training workers in a particular skill set, expanding your factory. Then taking from your ERP, you're bringing those work orders down into your production scheduling tool, whether that's an Excel spreadsheet, a more sophisticated tool, or even doing something on a whiteboard. And you're taking those sales orders, you're putting them in sequence. And it's going to support decisions such as, should we be working overtime this weekend? What's my prioritization between order A, order B? Capacity to promise. If sales calls with a hot order, can I fit this into the schedule? And if I do, what's the impact going to be on other orders? So planning, let's look at planning in a little more detail. Like we said, you've got your forecast coming in, you've got your stock positions of your purchase materials, you've got your sales orders. And coming out of that are your projections of what you're going to make. Now, what we're going to do is we're going to look at a make-to-stock scenario here. So on the left here, we see that I'm projecting that in April, November, and December, my forecasted shipments are going to exceed my ability to produce in those months. So what I will do is I'll take that excess production in December, I'll pull it into November. But November is still going to be overbooked. So I'm going to pull that excess, put it in October, pull some into September as well. I see in April I've got excess demand, so I'm going to pull that into March. I'm going to have to pull some into February as well. And I see that's what my constrained plan looks like compared to the non-constrained plan. So why is production scheduling important? Well, we see when we do a planning function, we've got the process time, we've got the setup time, and we're using standard times for our setup. We don't actually know the sequence we're going to run these in, so we're using standards, which may or may not be correct when we actually determine the sequence of the orders. So we've got our plan put together, everything's okay, right? Well, depending on the sequence that we put together our schedule, we may find ourselves in a situation where our equipment is overloaded and we're going to have late shipments. What we can do is, with detailed scheduling, we can take things and group them together. Let's group our orange product here, reduce the setup time. By grouping them together, we eliminate setup time. Group the gray, the blue. So we've got a capacity gain, and if we have high demand for our product, any capacity gain ends up being more product out the door, profit going directly to the bottom line. So what are different techniques that manufacturing plants use to solve their scheduling challenges? Well, it's common for, as things get more complex, to just hire more planners to do the work. Coordinating between those planners becomes complex, and there are limitations. Not only do you have the cost of labor, but there's limitations to just throwing more labor at that process and keeping it as a manual process. And of course, there's efforts across manufacturing to purchase ERPs to get rid of all the disparate systems, to increase efficiency by getting rid of all the disparate systems that manufacturing plants have. But there's limitations with ERP systems as well, and we'll take a look at that momentarily. And spreadsheets is another option, most common option for solving production scheduling. Spreadsheets, you've got your planners with a lot of tribal knowledge. They know how to work those spreadsheets. They're manually working the process, and you're at risk if that planner leaves, that all that tribal knowledge leaves with them. It's not efficient, not able to collaborate. Only one person's got visibility to that spreadsheet at a time. And it's very difficult to respond to disruptions which happen throughout the day. ERP tools. ERP tools, challenges there that ERP tools use a standard lead time. They don't have visibility to whether the factory is actually loaded or not. And using those standard lead times, you may end up purchasing your purchased materials before you need them, or at the other end, you may end up overbooking the factory and then be challenged to get orders out on time. So, in APS stands for Advanced Planning and Scheduling. What kind of concerns would an advanced planning and scheduling system have to take into consideration? It's going to have to be concerned with the fact that your equipment has a finite capacity, your labor skill sets have finite capacity, you've got equipment that is available only certain times of the day, they have breakdown that you have to work around, or planned downtime that you've got to work around. You've got to manage your WIP stock levels. In this example, copper wire. Copper is very expensive, and your levels of finished goods and WIP have a significant impact on a company's profitability. Subcomponents. If you end up being short one subcomponent, you can shut down the entire assembly process. Shutting down one work cell will shut down all the downstream processes as well, and that can be very costly. Bottleneck resources have to be supplied. The technical constraints, whether that is allergens, non-allergens, in the food industry, or maybe with assembling aircraft engines, regulations put in place by the FFA. You've got the availability of staff and the skill sets of the staff that are available. And of course, always meeting your promise dates is job number one, and it has to be considered. So it's a big balancing act to put together that plan. You have to create the right balance of what is going to be put on what resource at a given time. And there's many ways to sequence a set of work orders. So in a simple example, I want to demonstrate to you that the sequence of 1 plus 2 plus 3 is not the same as a sequence of 3 and 2 and 1. If we take order X, Y, Z and put them in sequence, using this simple example, 1 machine, 3 orders, it's going to take us 11 days to produce those orders, get them out the door. But if we just change the sequence to Z, Y, X, we see now that it's 8 days to complete those orders, assuming that there's nothing else on those pieces of equipment. Then if we were to introduce sequence-dependent setup time, the problem gets even more complex. So, in fact, there are many, many, many ways to sequence a set of work orders. Scheduling is an NP hard problem, and my apologies for using a obscure mathematical term, but the point is there's no mathematical solution. If you were to try to enumerate all the possible combinations, it becomes too numerous. For example, 10 operations on just one resource, you would have over 3 million possible combinations. If you had one more operation, the number of combinations increases by 1,000%. So if you can compute 1 billion combinations per second, finding the optimal solution for 30 operations would take 8 quadrillion years. But let's say we do get to a plan. Are we done? Well, everyone has a plan until you get hit, says Mike Tyson. And manufacturing's getting hit every day, every hour. You've got order amendments coming down all day long. You've got material disruptions, rework, equipment failure. Some processes are running faster than planned. Other processes are running slower than planned. All those things cause your schedule to get out of sync. And when it gets out of sync, it takes time, and you know, an APS needs to have the flexibility to get you back in sync quickly, considering all those other complex constraints that we discussed. So in summary, APS provides the heavy lifting. It'll consider the availability of the equipment, the manpower, the materials, and whatever other constraints that you have in your manufacturing process. It can balance lowering the inventory levels against having shorter lead times or increasing your on-time deliveries. You can understand the full impact of breakdowns and shortages and staffing issues immediately, where doing, using Excel spreadsheets, sometimes it takes a couple days before you are able to figure out the impact of taking a hot order and forcing it into the schedule. You can react quickly to protect your key customers' deliveries. And what we've seen is that an advanced planning and scheduling solution can have a dramatic impact. It'll increase plant productivity, reduce your raw material stock, reduce your work in process, have improvements of on-time delivery. All this while making the job less stressful, less time to put together the plan. And the return on investment, because these are real savings that can be quantified, the return on investment can be a short number of weeks instead of months or years. So that's it. Thank you for your participation today, and look for you in the ongoing webinar series.